Hello, everyone. My name is Ian Ording, and today I will be taking you all through the concept of IPv6 tunneling, what that means, and why it is used. So first and foremost, before getting into the actual meat of tunneling, we need to understand what IPv6 is and why the internet is pivoting to it. The primary reason is network address translation, or NAT, and the IP address naming conventions of IPv4. While they have been fairly successful, but just due to their natural limit in terms of amount of available IP addresses, unique IP addresses, we will need to implement a new strategy when it comes to IP addressing. IPv4, with the help of NAT, can accommodate 4.3 billion unique IP addresses, which is a solid amount, but one that will be overtaken at some point in the future, and therefore the switch to IPv6 would prove necessary and would allow for 340 trillion addresses, a number so huge that it should prove to be effectively limitless. That is, humans would most likely never have to change the way IP addressing works, because we would never run out of unique IP addresses. In addition to that benefit, IPv6 does offer better transmission of audio and video data, as well as other general benefits of being better technology. So let's discuss tunneling. An IPv6 world would allow for more dynamic internet than the current IPv4 does, and would allow it to continue growing without fear of running out of unique addresses. Once all the routers in the internet's core have been converted to IPv6, it can be the standard without caveats. The problem is that is a lot of routers, like a ton of routers. It would be impossible to replace them all quickly simply by virtue of how many routers there are across the globe and in the network core. And in addition to that, it would be prohibitively expensive to do that too quickly. So they are being replaced. The IPv4 routers are being replaced with IPv6 ones, but it is not happening all at once. As a result, there are still many IPv4 routers out there, more than IPv6. And as a result of that, the IPv6 packets must be able to work with IPv4 routers, which is where tunneling comes in. So the main reason for tunneling is the header of both types of packets. The IPv4 and 6 headers contain very different information, and are laid out differently and are different byte lengths. An IPv4 router would not be able to process a packet with an IPv6 header. Therefore, the IPv6 datagram has to be temporarily converted into IPv4 when it comes in contact with an IPv4 router. That way, IPv4 routers will have no problem sending datagrams as normal. To do this, the IPv6 datagram, including its header, is given an IPv4 header, thereby becoming effectively an IPv4 datagram temporarily. This is an illustration of the general basics of how that works. Essentially, in the same way that on the left, the IPv6 data would be the start of the data after the header. Instead, the start of the IPv6 header becomes the start of the payload data of the IPv4 datagram. And then that packet, once it reaches either its destination or another IPv6 router along its path, the header will be removed and it simply becomes IPv6 once more. As great as all that is, there are still some complications that arise from encasing the datagrams in IPv4 headers. Since the header and routers used in these scenarios are of IPv4, the error messages that will be returned to the sender will be IPv4 errors. Therefore, whatever client sent the IPv6 datagram must be equipped to understand error codes and messages of both protocols. In addition, the added header will also obviously increase the size of the datagram. The sender will attempt to send a ping along the route, not unlike our traceroute application, to determine the MTU that will be needed in addition to the added space. But sometimes things happen, and if the datagram does end up trying to pass through a router that it is too big for, it will simply be dropped and will not be further fragmented, as IPv6 only allows for fragmentation at the destination or source of the datagram and not on routers throughout the path. Thank you for listening and have a wonderful weekend.